All right, so we went over this in class already, so I'm going to go through these videos very quickly. But this one, we're going to be working on section 5.2. And all we're going to do here is to create a probability distribution, right? So we've already done the frequency distribution earlier in chapter 2, but now we're going, a discrete probability distribution, right? And that's just going to be creating a table, right? And a discrete probability distribution consists of values, of the values a random variable can assume and the corresponding probabilities of that value. So the probabilities are determined theoretically or by observation. When you're creating a probability distribution, the sum of all the probabilities in the sample space must be equal to 1, because we know whenever we're performing or looking at an event that has probability, that when we add up the odds or the probability of each event, that it will always add up to 1. And the probability of each event in the sample space must be between 0 and 1. So if you have a table that has a negative 0.3 and then a positive 0.7 and then another positive 0.6, although this would add up to give us 1, it could not be a probability distribution because we can't have a negative probability. All right, so each probability must be between 0 and 1, and they must add up to 1. All right, we're just going to go through this really quickly, like I said, because we did this already in class. So in section 5.2, all we did was construct a probability distribution for rolling a single die, or construct a probability distribution, and then we graphed it. So when we're doing this, we need to write out two different things. We need to write out our outcomes, and we'll put that as x, so it's our random variable, and then the probability of x. So our outcomes for rolling a single die is we can get a 1, we can get a 2, we can get a 3, a 4, a 5, or 6. Well, when we're coming up with the probability for each one, we need to look and say, well, what are the odds of rolling a 1? Well, we have 6 numbers we can get. So we have a 1 out of 6 chance of rolling a 1, a 1 out of 6 chance of rolling a 2, 1 out of 6 chance of rolling a 3, and so on. Right? So when you're creating this, all you're simply doing is just writing all of your possible outcomes, so all the possible outcomes that we can get, and all the probabilities of each outcome. And then when we want to graph this, we just create our axis, and then what's our y value is our probability. So since they are increasing by 1/6, I'm just going to have each of my tick marks represent 1/6. So it'll be 2, 6, 3, 4, 5, and 6. So it'll be 3, 6, 4, 6, 5, 6, and 6 over 6, or 1, obviously. Or we could have done it any other way. And then our x-axis is our outcomes, but we don't start at 0 here, so we can just, whatever number we're starting with, we can just write it out. So 1, 2, 3, 1, 2, 3, 4, 5, and 6. So if one of our outcomes is 0, we wouldn't write or start with 0 here. We would write 0 first. And then we just draw a line. So at 1, we have a probability of getting 1/6. So we just draw a line going up to 1/6. A line going up to 1/6 for all of these. These will all be exactly the same. Whatever they would be on a normal, if it was more than 1/6, if one of these were more and one of these were less, then we would draw a line going up to their probability. So this is all we did in section 5.2. It's just creating a table. So we created the table, and then we graphed the table. And our probability was our y-axis, and our x-axis were our outcomes, and we just draw these lines going up at each outcome to whatever probability they can have. All right, so that is it for this section, but we're going to continue section 5.3 on the same video. So in section 5.3, we were taking those probability distributions and we were finding the means of it. So what is the average? We were finding the standard deviation, and we were finding our variance. So I'm going to go through by hand how to find your mean here, and then I'll show you or tell you how you can do it on a calculator as well. But if we want to find the mean, so it says the probability distribution shown represents the number of trips of 5 nights or more that American adults take. So what this means is that 6% of American adults take 0 trips that are 5 nights or more. 70% of American adults take 1 trip that is 5 nights or more. 20% takes 2 trips that are 5 nights or more, and so on. So it says find the mean. So what we're trying to figure out is how many trips does the average adult take that are 5 nights or more? And it's really simple. All we do is we multiply the outcome and the probability. So we multiply all the outcomes and probability, and then we add them together. So it will be 0 times 0.06 plus 1 times 0.7 plus 2 times 0.2 plus 3 times 0.03 plus 4 times 0.01. Well, we know this is 0. This will be plus 0.7. This will be plus 0.4 plus 0.09 plus 0.04. These two will add together to give me 1.1. These two will add together to give me 0.13. So when we add them, it'll be 1.23. So that means on average, the American adults in America take on average 1.23 trips that are 5 nights or more. So slightly more than one trip. Each American adult will take slightly more than one trip that is 5 nights or more. Right? And that is our mean. Now, something that we learned before when we were dealing with our probability distribution, our frequency distribution earlier in the year, we knew that we can put this in our list 1 and this in our list 2, and we can use our calculator. So what you would do if you're using your calculator is you'd fill in your outcomes to list 1 and your probability to your list 2. Right? Then you would click your stat button, and then you will edit. And in your list 1, you will put your outcomes. So L1, I'll just put L1 will be equal to our outcomes, and L2 will be equal to our probability. Then you will press your stat button again. This time you will scroll over to your calc button, calculate, and then you will click on one variable test. And from here, you will get 2 options. You will get list and you will get frequency. Your list is your outcome, so it's L1. Your frequency is your probability, so it's L2. And then you will go ahead and click the calculate button, and that will tell you what your mean is. And it's also, so it'll give you your mean. And then what we're going to actually talk about next, it's going to give you your standard deviation. So this is how I would suggest you do it going forward, is using your calculator. Sometimes it might be a little bit easier or quicker if there's only a few numbers that you need to multiply. But I would suggest using your calculator. It'll be a little bit easier for you and it's more direct. All right, if you need help with your calculators, please just let me know. All right, if you wanted to go ahead and solve your standard deviation by hand, here's the formula, but I'm not going to make you do it by hand because we've already calculated this when we did our frequency distribution by hand earlier in the year. It's the exact same thing. If you remember, we did our midpoint midpoint squared times our frequency, and then we did our midpoint times our frequency. We add them up. It's pretty much the same thing that we're doing here. So we don't need to go ahead. I'm not going to force you to do it by hand since I've already done this with you earlier in the year. So I would suggest you use your calculator. You will get this formula though. So if you want to do it by hand, by all means. All right, so for this one, it says a box contains 5 balls. Two are numbered 3, 1 is numbered 4, 2 are numbered 5. The balls are mixed and 1 is selected at random. After a ball is selected, its number is recorded, then it's replaced, so we put it back. If the experiment repeats many times, find the variance and the standard deviation of the numbers of the balls. So the first thing we would have to do for this is we have to create our chart. The last one they gave us the chart. But we have our outcomes and we have our probability. Well, our outcomes are we have a ball that's number 3, we have a ball that's numbered 4, and we have a ball that's numbered 5. So those are our outcomes. Then we have to find a probability of each one, where there's 2, 1, and 2 balls. So there's 5 total. Well, 2 of them are 3, so that means 2 out of 5 are 3 balls. There's 1 that's numbered 4, so it's 1 out of 5. And then there's another 2 that are numbered 5, so it's 2 out of 5. All right, so what we would do is we will put this in our list 1, this in our list 2. Then we will press calc or stat. Scroll over to calc, one variable test. Make sure that your list is L1. Your frequency is L2. Then press calculate. So after you type this into your calculator, you will get that your standard deviation is equal to 0.89. So our standard deviation is 0.89. And if we want to find our variance, we need to square our standard deviation, and that will be equal to 0.8. All right, so If you're having trouble with this on your calculator, please let me know. All right, now there's one more thing we discussed in section 5.3, and we'll go over, I think it's one more question, and that's it for this video. All right, so the last thing that we need to discuss is called our expected value. And our expected value is the same thing as our mean. So we solve for it the exact same way. And what our expected value is telling us, so the expected value of discrete random variable of a probability distribution is the theoretical average of the variable. So it's telling us if we are going to gamble our money, or if we're going to buy a lottery ticket, or if we're getting life insurance. It can tell us on average what we can expect to make or lose. So if we're losing money on average, then maybe it's not the best deal for us, or the best bet, or the best whatever. And if we're making money on average, then maybe it's the right investment, and so on. So it tells us what we could expect on average if we were to continuously do this investment, or continuously do this lottery, or whatever. If we were continually to play this, we could expect what to win or lose every single time we do it. Right? And it's the exact same as our finding our mean. Right? So actually there's two questions we're going to do. So for this one, we need to create our frequency, our probability distribution. So we have our outcomes and we have our probability. So in this case, we have two outcomes that can happen. If we win $350. However, we spent $1 on our ticket, so we really actually only win $349. And when we lose, we will lose $1. So those are our two outcomes. If 1,000 tickets are sold for a color TV, and there's only one color TV that wins, then that means we have a 1 out of 1,000 chance of winning the TV, and we have a 999 out of 1,000 chance of losing our money. So here's our expected value. We just find our mean. Now it's important that you put this as a minus because we are losing. If you put this as a positive, it will give you the wrong answer because it's acting as if you're gaining that every single time. So we could go ahead and multiply 349 times 1 over 1,000. This is one of the cases where I would suggest that maybe you do this with a calculator because it might be a little bit quicker. And then we can multiply it by 999 over 1,000. So we can do 349 times 1 divided by 1,000 plus -1 times 999 divided by 1,000. And that will give us an expected value, or an average, of 0.65 cents. So that means that on average, every single time that we purchase this ticket, we could expect to lose, on average, 65 cents. So it's not saying that we will lose 65 cents this time. It's just on average. So we may lose 30 times in a row. So that means we would lose $1 every single time. So we would be down $30. And then we win. So we're up 349. But on average, it will average out to be a loss of 65 cents. So since this is negative, it would mean that you wouldn't expect to win. So you probably shouldn't be buying this ticket every single time because on average, you're going to be losing 65 cents. All right, on average, that's a key thing that you have to remember there. It's on average. We either win a $350 TV, which is $349 after the $1 we spent, or we lose $1. We're not going to lose 65 cents and get some of our money back. It's just on average this occurs. All right, so this last question, it's talking about a bond investment and which one is a better investment. We have two bonds. We have bond X and we have bond Y. So we have to figure out which one should we invest in. So for both of these, we would have to create a probability distribution. So we have our outcomes and we have our probability. Well, our outcome is so let me just read the directions. It says a financial advisor suggests that his client selects one of two types of bonds in which to invest. Bond X pays a return of 4% and has a default rate of 2%. So when it defaults, that means we lose everything. So one of the outcomes is that we will lose everything. So we will lose the $5,000. And the probability of that happening is 2%. So that means it's 0.02 or 2% chance of losing the 5,000. Well, if we don't lose the money, it gives us a return of 4%. So that means that we don't get paid 5,000, but we get paid for 4% of that. And 5,000 times 0.04 gives us 200. So that means if it doesn't default, we're earning $200. So we're either making $200 in the blue or losing 5,000. And if it's a 2% chance of defaulting, that means we have a 98% chance of not defaulting and to earn our interest. So if we want to go ahead and calculate our expected value, we can do 200 times 0.98 plus negative 5,000 times 0.02. And when you calculate this, it'll give you $96. So that means on average, you can expect to make $96. It doesn't mean that you will actually make 96 because we know we're either making 200 or we're losing 5,000. There's no in between. It's just we may get our return 40 times in a row, then lose once, and so on. Right now, we would have to do the same thing for the bond Y. So we have our outcomes and we have our probability. So in this one, we have still $5,000, but it has a 2.5% return and a default rate of 1%. So once again, if it defaults, we lose all 5,000, but this time it only happens 1% at a time. Our return is not as good, so we're not getting a 4% return, but we're getting a 2.5%. So a 2.5% return is giving us $125. So it's a little less, but it's more likely to actually give us the return. It's less likely to default. So if it's 1% default, that means 99% of the times we will get a return. So if we want to find our expected value, same thing, we just multiply these together and we add them. So we would get 125 times 0.99 and then plus negative 5,000 times 0.01. And that will give us a return of expected return, an average return of 73.75. So since this bond gives us a higher expected return, this is the bond that we should invest in because on average we will get higher, more money back. Now someone might say, well, let's invest in this one because it's less likely to default, but it's smarter and better to do bond X because on average you're going to get more of a return. All right, that is it for this video.